The solution is spine and leaf design, or the cloud networking model. This is how it works. First, we only have two layers. This layers, we call it spine layer. I'm going to create two spines first, SP1 and SP2. I also have the other layer. We call it leaf layer, leaf 1, leaf 2, and leaf 3. Okay, there you go. Now, leaf 1 or leaves are also can be similar or analogous to our access switches, or I can also connect these leaves to our servers. Okay, connect these leaves to servers and more servers. There you go. Now, leaves connect to the spines. Our leaf 1 connect on both spine 1 and spine 2. Same with leaf 2. Leaf 2 connects to spine 1 and spine 2. Same with leaf 3. Okay, as you can see, the connections are very consistent. Now, the good thing about this spine and leaf design is everything is consistent. The pattern is very obvious. If I add leaf 4, I will connect this to spine 1 and spine 2. Now, it is scalable, meaning that I can add up to, let's say, hundreds of leaves. Let's say this is leaf 100. Okay, if I can scale our leaf layer, that means I can also scale our spine layer here. I can add spine 3, okay, and this spine 3 connects to all leaves. Leaf 1 connects to spine 3. Leaf 2, leaf 3, leaf 4 connects to spine 3. Now, like leaves, it can also be scaled. I can add, let's say, up to spine 8. Now, for a medium-sized environment, spine 2, 3, or 4 is enough. But for a very large data center environment, it is possible that you can reach up to spine 8 or even up to spine 10. Okay, as you can see, everything is scalable. Okay, from the leaf layer and to the spine layer. Now, maybe you're thinking, how can we connect to the outside world? Where is the core layer? Okay, where is our core switch? Now, there's no core switch, but here's how we connect to other networks or other or the outside world or the public networks. It is also gonna be using the leaf switches because spines doesn't connect to any device, only to the leaves. And also spines and spines doesn't connect to each other. How about leaf and leaf? Well, ideally they don't, but there are some cases that they can connect or communicate to each other. We're going to talk about it in a bit. Now, as I mentioned, in order for this data center to connect and access the outside world, we will be using a router. And this router connects to our leaves. And this router connects to the outside world. Now, maybe you're thinking, what is this leaves? Are they special leaves? Well, they call this border leaves because they are connected to the router and the router connects to the outside world, making them as the border device. But you can connect this layer 3 device or the router to any leaves. As a matter of fact, in this example, we have leaf 4 and leaf 100. Okay, they are still using some of their ports connecting to some servers. The idea of this spine and leaf model is we want to have a data center that can be easily managed and we can push automation configuration easier. As a matter of fact, if you look at the pattern where we have multiple spines and multiple leaves, both are scalable. it can be analogous to a chassis-based switch. If in a chassis-based switch, if you want to add more ports because you want to add or connect more switches, or excuse me, if you want to connect more servers in your data center, all you need to do is add more Ethernet modules or line cards. Okay. Now in a chassis based or in a modular based switches, if you want to have a better backbone, a better congestion management, you need to add more fabric module or fabric switch. Now, leaf switches can be analogous to line card or Ethernet module, and spine switches can be analogous to the fabric module or the fabric switches. Our goal is to have a data center that it would look like a gigantic switch where we can easily manage, easily monitor, and enable programmability and automation. Here are some disadvantages of our legacy data center network architecture or our three-tier hierarchical network model. These are oversubscription, interact latency, design limitations due to spanning tree protocol, where effect would be some of our ports running in our switches will be in a blocking or discarding state. As a result, switches are not fully utilized. The solution will be cloud networking model, also known as our spine and leaf architecture. And this works if we have more lateral or east to west traffic versus north to south. 20% for north to south, more or less 80% east to west, because our servers needs to communicate to other servers for lookup, analytics, storage, API caching, and other server related communications. This non-blocking, two-tier designs, 2 layers, only spine and only leaf layer. No STP design limitations, and switches are fully utilized. You will not see block ports, and there will also be a lot of advanced features that can also enable in this new architecture, spine and leaf model. And take note, with this model, it's highly scalable. You can add hundreds, if not thousands of leaves and more spine switches for better backbone. Other benefits of our cloud network architecture or spine and leaf: no oversubscription, low interact latency, configuration consistency, and simple network pattern. So if our leaves connects to these 2 spines, we can see it as spines connects to leaf 1 via E1, spine 1 connects to leaf 2 via E2, via E3 and E4 connecting to leaf 3 and 4. And this interface numbers connecting to our leaves, we can use this same pattern to not just spine 2, but also to all other spines if you're planning to add one. How about the leaves? Well, it's almost the same, but in a traditional environment for spanning or spine leaf topology, we will be using a separate module connecting to our spines. Most of the time, we're going to use 40 gig QSP port or 100 gig. Okay, our QSFP ports, these are special ports in a different module. Okay, and these 40 gig ports, they are limited, maybe 4, maybe 6, but not as many as our 10 gig ports. Let's say we have 4 QSFP ports or the 40 gig. The first 40 gig will be used connecting to the spines. The second 40 gig port will be connected to the second spine. Okay, and you can also use this pattern to all leaves. Now, if you will be adding the third spine here, spine 3, you can connect all leaves using the third 40 gig interface. Now, take note, the communication or the connection from leaves to spines is a special connection. In most cases, especially in a medium-sized or large data center environment, this is 40 gig or 100 gig connections